For the first problem, we're going to be looking for the difference quotient for the equation f of x equals negative 5x to the third plus 2x. We're going to be using the difference quotient formula to solve it. So for every x, we're going to be plugging in x plus h. It's going to be negative 5x plus h to the third power plus 2x plus h. It's going to be negative 5, and it's going to distribute to 3x plus h's, then distribute the 2, so 2x plus 2h. So we're gonna multiply the first two x plus h's. We're gonna get x squared plus 2xh plus 2h squared. Bring down the x plus h, then plus and bring down the 2x plus 2h. Now you're going to multiply times the x plus h, and you're gonna get negative 5 x to the third plus h x squared plus 2x squared h plus h squared x plus 2x h squared plus h to the third, and then bring down the 2x plus 2h. Now you're going to combine like terms values, and you're going to get negative 5, get x to the third power plus h to the third plus 3x squared h plus 3h squared x, and then you're gonna bring down the 2x plus 2h. Now you're gonna subtract the original equation, which is negative 5x to the second plus 2x, and then cancel them on the top and bottom, and you're gonna get the final equation of negative 5 h to the third minus x minus 15x squared h minus 15h squared x plus 2h. And then you're going to divide all of that by h. So we're going to cancel all the h values on the top and the bottom. And you're going to get negative 5 h to the second minus 15x squared minus 15hx plus 2. And that's the difference quotient for the answer.
For problem number 2, we're going to use a fx function equals x squared minus 5x and gx function x squared plus 3x plus 4. The a is f of g, x, so we're going to plug in the gx function for every x in the fx function. Now we're plugging the first x squared plus 3x plus 4 squared, because over there is squared. Now it's minus 5, parentheses x squared plus 3x plus 4. And then now we're gonna separate those two and multiply them by each other, and it's gonna be x squared plus 3x plus 4 times x squared plus 3x plus 4. Now we just should use distributive property for that other part of the function. Now this is where you use distributive property for that part of the function, and it's gonna come out to x4 plus 3x cubed plus 4x squared plus 3x cubed plus 9x squared plus 12x plus 4x squared plus 12x plus 16. And we're gonna leave the other part of the function up there to not confuse ourselves. Now we drop down the other part of the function and we combine like terms. Of course, that's where we're gonna cross off this and that. And after you combine all like terms, the final answer is gonna be x squared plus 6x cubed plus 12x squared plus 9x minus 4. Now for b, it's gonna use g of f, so we're gonna plug in. For every x in the g function, we're going to plug in the f function. So it's going to be x squared minus 5x squared because of the g function, plus the 3x x squared minus 5x. Then we can't forget the plus 4 at the end. Now, we're going to separate here, so that means multiply by each other. So we're going to do x squared minus 5x times x squared minus 5x, plus distributive property there, so we're going to use plus 3x squared minus 15x plus 4 at the end. And once we're going to use distributive property there, now it's going to come up to x4 minus 5x cubed minus 5x cubed plus 25x squared plus 3x squared minus 15x plus 4. Now we're going to combine like terms, and the final answer.
For problem 2c, you're going to be using f of f, and for every x, you're going to be plugging the f of f equation. So it's going to be x squared minus 5x squared, and then minus 5x squared minus 5x. And then you're going to distribute the squared. It's going to be x squared minus 5 times x squared minus 5, distribute the negative 5 to the other equation. Now you're going to multiply the 2x squared minus 5, and you're going to get x to the fourth minus 5x to the third minus 5x to the third plus 25x minus 5x squared minus 25x. And now we're going to combine like terms. It's going to be x to the fourth minus 10x to the third plus minus 5x squared. For problem D, it's going to be the same thing as C. So for g of g, you're going to plug in g of g equation for every x. It's going to be x squared plus 3x plus 4 squared, then plus 3, x squared plus 3x plus 4, and then bring down the 4. It's going to be x squared. That equation is going to be to the second power. It's going to be x squared plus 3x plus 4 to the same thing, and then distribute 3x, and then bring down the 4. Now we're going to be multiplying x squared plus 3x plus 4 to itself. And so in order to not cram everything up, you're just going to keep the other half on the top and combine the like terms. So you're going to end up getting x to the 4 plus 6 x to the third plus 17x to the second plus 24x plus 16, and then you bring down the top half, and it's going to be plus 3x squared plus 9x plus 9 plus 12 plus 4. And then you're going to combine all of those to find the like terms, and the final answer is going to be x to the fourth plus 6x to the third plus 24x to the second plus 33x plus 32. And that's going to be the final answer for D.
So now for problem number 3, we're going to use the rational root theorem and find all zeros. And we're going to use the function which is above. We're going to use the leading coefficient and the constant, which is 2 and negative 9, and divide those. And whatever we get is what we're going to use to factor. So we're going to use matrices, and we're going to start off with plus or minus 1. So the 2 drops down, and 1 times 2 is 2, 5 plus 2 is 7, 1 times 7 is 7, and here's 3 plus 7 is 10, 1 times 10 is 10, 15 plus 10 is 25, 1 times 25 is 25, and negative 9 plus 25 is 16. That doesn't work. Now the next is negative 3, so 2 drops down again, negative 3 times 2 is negative 6, negative 6 plus 5 is negative 1, negative 3 times negative 1 is 3, 3 plus 3 is 6, negative 3 plus 6 is negative 10, 15 plus negative 10 is negative 3, and now 9, negative 9 plus 9 is 0, so that does work. Now we're going to use the half, so the 2 drops down again, 2 times half is 1, 5 plus 1 is 6, half from 6 is 3, 3 plus 3 is 6, half plus times 6 is 3, 15 plus 3 is 18, half times 18 is 9, negative 9 plus 9 equals 0. That works out.
Since you only found 2 of the 4 zeros that you need, you're going to have to find the other 2 zeros using the previous equations that you got from the factoring. So you can use either one, or you can use 2x to the third plus 6x squared plus 6x plus 18, and then you can just divide by 2, and then use that equation to find another factor. And you can use the negative 3 since it's already a 0. So you're going to bring down the 1, it's going to be negative 3 times 1, negative 3, 0, then 0, bring in 3, 3 times negative 3, negative 9, that makes a 0. So that's going to give you the equation x squared plus 3. And with that one, you have to use the quadratic formula to find the other 2 zeros. It's going to be plus minus square root of negative 4 times 1 times 3, and then divided by 2 times 1. So you'll get plus minus the square root of negative 12 divided by 2. But since you can't have a negative inside, you're going to put an I outside. And you can factor out the 12 inside and make it 4 times 3. And the 4 factors out into a 2, so it's going to be plus minus 2i to the square root of negative 3 divided by 2. And you're just going to rewrite it. So it's plus 2i square root of 3 divided by 4. And you can cancel it 2 and 4 and make it plus minus square root of I square root of 3. So those would be the 2 other remaining zeros. Hi, I'm Vanessa Garza.
Hi, I'm Albert Garcia.
And we're part of Group 14.